Hello and welcome to the Erlang Solutions monthly webinar. My name is Martin Milicic and I'm the VP for EMEA region here at Erlang Solutions. Today's webinar represents a continuation of a series of webinars we have been running across topics of interest in the world of Erlang and dealing with solutions based on the Erlang programming language. Specifically today we will try and tell you a bit about how Erlangers think. We regularly hear from people starting with Erlang, and the most common comment that we get is that Erlang is easy to pick up. However, the issue often lies in changing the way one thinks. That indeed seems to be the real challenge of taking on the Erlang paradigm. As you know, Erlang is based on a couple of core principles such as share nothing processes, fail fast, and failure handling. Now, today's webinar will specifically talk about how to design systems with asynchronous message passing between processes that do not share any memory. And to give you an example, we will be using Conway's game of life, which poses a couple of questions relevant to issues in implementation that apply to all asynchronous message passing solutions. To just tell you that, as with any live event, we may obviously experience a couple of technical issues, so please bear with us in the case that happens. But to start by telling you a bit about Erlang Solutions, we are a products and services orientated company completely devoted to the Erlang programming language. Since we started in 1998, we have worked with organizations and individuals using Erlang. We've been helping to evolve the language, and we have been working with organizations that are sort of furthering the Erlang cause. Today we have just over 100 people sitting across our offices in London, Stockholm, Krakow, Budapest, Seattle, and Buenos Aires, and working on projects across the world, really. We are very keen on creating value and competitive advantage for our customers across industries and through the unique features and characteristics of Erlang as a language. We are equally ambitious in developing Erlang-based products, and some of those include our Mongoose IM messaging platform, the React distributed database, and Wombat OAM, which is a monitoring and management technology for Erlang systems, as well as many other solutions that we develop and that are applicable across sectors and problem areas where Erlang obviously makes sense. Now, I'm particularly pleased to say that our speaker today is Torben Hoffmann, the CTO of Erlang Solutions. Torben has spent a number of years as a self-confessed Erlang priest, advocating the use of Erlang across industries and helping businesses and individuals benefit from Erlang and Erlang-based technologies. Torben will give us a first-hand account on what it really means to think like an Erlanger and what obstacles typically present themselves on that journey. Now, please allow me to finish by saying you are very welcome to pose questions throughout the duration of the webinar by using the chat facility on the webinar's interface. Our speaker, Torben, will answer as many questions as time allows at the end of the webinar. If any questions do go unanswered, you're welcome to raise them via email using the following address, webinar@erlang-solutions.com. I will now gladly hand over to Torben Hoffmann, who will be glad to start us off with the webinar.
Thank you, Martin. And one of the things that Martin mentioned before, that it's difficult to pick up how to think like an Erlanger. And one of the reasons is if you take a map of existing programming languages and you look at how they relate to one another, most of these maps never show Erlang. It's an outlier. It's an alien that came down from space. And it was given to Earth by another alien, Joe Armstrong, who did wonderful things to put ingenuity into the language. So if you come here and you want to learn how to think like an Erlanger, so you probably want to see the Erlang code. I will have to warn you here. You can't handle the Erlang code. This is not about code as such, because syntax is irrelevant. Anybody that will come along and say that syntax has anything to do with thinking, they need to have their heads examined, and you probably also want to avoid working with. Thinking, on the other hand, is everything. If you do not know how to think with the tools you're using, then the tools will not become a natural extension of yourself, and you'll end up doing horrible things like, for instance, writing Python-like code in Erlang. Don't do it. It's horrible. Embrace Erlang instead. So let's go into this. So there's something here about Erlang and where it comes from and how things are fitting. So Erlang originally comes from telecom, and that is a vast area of fun stuff. If you take a general purpose language like C++ or Java, just to take some of our favorites, you'll see that the amount of code you need to do to fill out the needs of telecom is quite large. But on the other hand, you design a language to be fit for telecom, like Erlang, you get a much smaller gap. And that gap is actually important. One of the things that makes it important for you if you're a developer is that you can sit down every day and have fun, because the amount of code you need to put in place to solve the ideas, solve the problems in the domains you're looking at is going to be very small, as long as the domain fits the requirements or the characteristics of telecom. Fortunately, a lot of modern web server domains fit those requirements, so that's why Erlang is a good fit. If you, on the other hand, is more into making business and everything, then that smaller gap you have here actually equals money, because you can be a lot more productive and deal with errors creeping up a lot easier in Erlang, because you have less code to worry about. All of this then comes back to what are the key points Erlang is made for. So it's actually about protocols. Erlang is made for telecom, so it is very good for dealing with protocols. And I can recommend both of these books here. Hoare's book is something everybody should read, not just because it's Tony Hoare, but more because it's a very elegant book on how to think in terms of having processes that does some sort of communication with one another to get things rolling, which is basically what you have in Erlang with all the processes and the message passing. If you want to take it a step further, I had to do that while I was studying. You have to buy this enormously expensive book from Springer. It comes in at $120, just to make it a little bit pricey. But it's actually a very, very good book that talks about all the things involved in designing protocols. And one of my pet peeves in software engineering in general is that all the stuff people have been doing in telecoms to deal with protocols and make them well described is something that every software engineer should have a look at. Because at the end of the day, it's not what you put inside a module or an object or whatever, it's the interaction with other objects, modules, and processes and what have you that's important. And that's where the bulk of your energy should go when you're designing software systems. An example of how you describe things, so you have the Paxos protocol for solving things related to message secure passing of messages and making sure everybody has it. It's used in REAC, the NoSQL database, and there's a wealth of protocols out there. You can go on Wikipedia and see how they work. And the beautiful thing is that it's very easy to implement them in Erlang. But the thing is here that's important is that you describe them by these things called message sequence charts, where you show the different entities involved and what messages they're sending to one another. So now we come to this one that I'm throwing around left, right, and center when people ask me what is the important core of Erlang. And this is the golden trinity of Erlang. So this is what also Mladen mentioned in the beginning. You have share-nothing processes that cannot share memory. You can only exchange things between the processes by sending messages. Then you have fail-fast. So this is the notion of if something goes wrong, don't try to be a hero about it, just die immediately. And in order to counter that approach and actually make software that runs, you need to have failure handling. And these are the three pillars upon which Erlang is built. You will not find any other languages that have this particular mix of these features done in this elegant way as Erlang has it. So this is what makes Erlang so different. This is why it doesn't fit in over a chart of inheritance of programming languages. This is the ingenuity of Joe Armstrong and the computer science lab at Ericsson that is coming to its full glory. So, first thing is processes. You have to use a lot of them. Really, really, really a lot of them, because they're dirt cheap. The Erlang VM is amazing. You can spin up hundreds of thousands of them, or millions of them, and it will just with next to no overhead in it. It's not like a big fat thread in an operating system there. And then apart from then using a lot of them, then you have to focus on the interactions or protocols, as I mentioned before. So now we're going to do something here that if this was broadcast out of the US, it would probably say, don't try this at home. I'm going to talk about the game of life and how you could do that in Erlang. So game of life is a simple cellular automaton where you have a number of cells that are evolving over time depending on their neighbors, and it happens in discrete time, so you have time ticking at a regular interval, and then things are moving along according to that. So I'll just go into the bit about the rules of this automaton so we can understand what it is we're talking about. So here you can see with the cell marked with a black cross is one cell that we're concerned about. It has a number of neighbors marked with a fancy purple color around it, and the rules of the game is that if you have 2 or 3 neighbors, you will survive. If there's an empty space and you have 3 neighbors, it will give birth to a new cell. And all other cases here, then the cell in the next generation will be empty. The field on the board will be empty. So let's see. Here I've created a little colony of cells, and let's see what happens as time progresses. So here, time is at the beginning, and then we have one time step, and you can see how the cells multiply, die, or stay alive. And here we can see there's another one here. And notice here, and you probably, if you know the rules of the game, you probably already calculated that there's something weird going on. These worlds, they wrap around at the top and bottom and on the side, left and right hand side, so it's like a round world collapsed into it here. But I'm showing it in 2D for the sake of the medium we're having here today. Yeah. So you can see it progresses along here. And this one looks actually to be doing really, really well, this initial configuration here. And we see times 6, and we go on. And actually, I wouldn't take you through the end, but I think this, as I recall it, this one lasts for 19 generations before it dies out there. Now, doing this is something that a lot of people have done in their computer science education, because it's such a nice problem, simple rules, and everything. And the traditional way of doing this is you do it with a 2D array. And you then have one array per time step, going from one time to another. You take the old array, and then you look at that and compute the values of the cells in the new array, which is the next time step in the sequence. Now, I will then claim that there are some issues with the traditional approach. And these are issues that will come to light if you go about and doing something quite extreme. It does not scale well. So if you run it on an enormously big grid with a large number of cells on it, it will not scale in getting things to run fast as you have more cores available, because it's basically a sequential solution you're having there. And then you have another thing is doing an imperative data structure is quite ugly in Erlang. It's really, really ugly to do the 2D array thing there, especially if you're getting into Erlang for good, and then, no, it's just not nice. Yeah. And then I've been told here that some people just go, wait a minute, this is insane. Solving game of life with processes in Erlang, it's never going to work. Well, I have measurements that on my machine, if you go to a 300 by 300 grid there, meaning you have 90,000 processes or cells in your game of life, then the process version is just as fast, if not faster, than the 2D array one. And then you can imagine what happens as you scale it up, because the process one is continuing to scale well, while the other one is just stuck in its ways. So, but we can take that offline if you want to discuss that with me. Anyway, so the basic Erlang idea, as you probably can see by now, is that just one process per cell. This is the key stopping thing for a lot of people coming into Erlang. They do not feel that throwing another process on the table is a good idea. It is. Try and think. You can always remove processes from your architecture, but throw one in and see if it works and makes things easier. Then you let these processes talk to the neighboring cells or the processes representing the neighboring cell, and then you can code the rules of the game of life. Yeah. So this means you have to have a protocol in place. And here is that when you want to update from one time step to another, you collect information from all your neighbors. You have 8 neighbors in this grid there, and you see if that neighbor is filled or not. And then, depending on how many neighbors there are, you can update the content of your own cell and then progress to the next time step. Now, as I told you earlier, we have to use processes, a lot of it. So the question here is this Erlang enough? If Erlang is a word you can use, but I'm using it. In fact, I started out by using this, and I realized you can actually make it more Erlang, or more Erlang in it. So you can spawn a process to collect information from all the neighbors. It has that nice benefit that this little collector process has a very confined job it has to do, so it's easy to write that code, and then you can leave it outside the normal cell thing that does other things to maintain the nature of the cell, and the cell will just start the collector will ask all the neighbors, and then it will send back to the cell when it has collected from all 8 neighbors how many neighbors there was around, and then the cell can update itself and go to the next time step. Yeah, and you've been good listeners so far, so I will actually show you some Erlang code, and I hope you can handle it. So here we have the collector loop. That's the little collector process I showed you before. There you can see at the top one that there is that when you're out of, we have an empty list of what you're waiting on, meaning you've received from all your neighbors. You just tell back to your mother cell, okay, this is what you have to change to because I've collected information, and this is where you have to go. This is your next content, either 1 or 0, being filled or not filled there. And then in the meantime, you have this where you're still waiting on some of your neighbors to get back to you and give you an information about the content of their cell. And then you have this receive where it says, okay, if it's one of the ones we're waiting for, then we will update our neighbor count with the content of the neighbor cell that just came back to us, and then we continue looping, as I said, until all neighbors have come back to us. Nice and easy piece of code there. And then you're looking at this, and this is, okay, there's a lot of different things floating around, processes and everything. Will this work? Actually, it works under certain conditions, which is also the trick. And this is where we now progress, and you have to be aware that from this point on, in this talk, we're going to be talking about game of life still, but the principles here in how you look at asynchronous protocols, and you try to figure out if they're doing the right thing or not. It's the same principle regardless of what problem you're looking at. Game of life, I've chosen it because the rules are simple and it's a fun one to work with, but it'll illustrate what you have to do in any Erlang system where you have protocols to deal with. So it works provided you only take one step at a time. So I have my huge collection of processes representing the cells of the game of life. If I just say, do one step, and then wait for all of them to finish, then it'll work. And if you let the cells run freely, to say, just go ahead, evolve over time, and just run on as fast as you can, then your cells would actually get out of sync. Because the minute you've received from all your neighbors, you will go to the next time step. And then you will not be able to talk to ones that are left behind in history. So that means that you'll get requests for old time. What was the value of your this cell back in the past? And you'll also get requests for future time, because as soon as a cell has progressed to T2, it'll start asking people around it for what is your content at T2, and they will still be stuck at T1, and they will have no idea what they evolve into, because they're still missing information from their neighbors about T1 in order to calculate what they will become at T2. So this is ugly, but it's the same ugliness you'll find in any asynchronous system. So let's see if we can deal with it. We can fix it. So old-time requests, meaning somebody is asking for things that happened in your past, you just keep a history. So a cell will just keep a history of what its values were at time 0, 1, 2, and so on. So that means you can, if somebody asks for you something in your history, you'll just look up in the history and give him the answer. Now, slightly more interesting is if somebody asks you, what is your value in the future? Since time travel and wormholes have not hit the Erlang runtime system yet, we have to deal with this in a different way. So you have to queue the response to the guy asking you. And this is something that often happens in Erlang, that if you don't know the answer right now, but you know you'll be able to answer in just a little while, you just queue the response, and the other one will just wait for you to be ready to answer. Now, this will handle these things. Then you come into something else. What about failures? Because this is one of the other things when we talk about designing Erlang systems, that systems will go down. Even a system written in Erlang will have failures and things going wrong. Anybody who claims that they are writing software without failures in it, well, they're probably not writing any code at all. So, yeah, that's my stance on it. So, what do we do in Erlang? You supervise the cells. So, the Erlang supervisor, and this is the beauty of it. So, an Erlang supervisor will restart a process with the original arguments used to start the process. And we can use that because even though you can do that, then you run into issue that all state and history is lost. So you will start from 0 with the initial value, and then you just have to say, how can I be part of this world where, if, for instance, if you've gone on to time 100, then you're just left behind everybody else there. So the trick is, the fix here is, you monitor all the cells in your game of life, and then when they die, you pick them up again, and then you step them forward to current time. So they will just speed through the history and get up to where everybody else is right now. And this can actually be shown in a supervision diagram. And this is how the code, I'm using here notation I've been working on for a bit called Visual Erlang. It's on GitHub actually, but I've done some updates since I last uploaded to GitHub, but I'll get the other updates up shortly. But here you see you have a top process here, and it has it kicks off a cell supervisor which is monitoring and supervising all the nice little cells in our game of life. And then we have another trick here, and this is the cell manager. The cell manager is the one responsible for making sure that the cells would actually catch up with the rest of the cells if they die. And that's because the cell supervisor, as we remember, it's a standard Erlang supervisor. The only thing it can do is restart a cell in its original state. So the cell manager is also monitoring these little cells, and when it detects them going down, it spawns up a process that I have called pacer that will pace the cell forward to current time. And let's see how that works here. So this is again an MSC, and I do recommend that all of you write down MSCs when you're trying to design anything. Erlang, Java, whatever. Write down MSCs. So here we have that a cell is going down, it runs into an issue, and it terminates. Then the cell manager is then waiting for this cell to be restarted. And the restart will happen from the cell supervisor that will just send a restart message to a cell, but basically it's doing a start link here. And then as soon as the cell has been restarted, the cell manager will start monitoring the cell and start a pacer process that will make sure that you can pace the process of the new cell forward until what is I've called here max time, because then I have a global clock process that actually allows you to figure out the maximum time any of the cells in your world has progressed to. And that is then the pacer asks that, gets it back, and then tells the cell, please catch up, and then you're back where you were before. So this is something that you will actually run into again in your live systems, that you have something restarting, and then you probably have some sort of, I need to calibrate with the world again. And depending on what calibration means in your particular case, you'd have to write out these MSCs and make sure that things are happening. But it is doable, and it's a lot more doable when you do it with MSCs instead of just hacking around, slapping code into an editor and hoping that you get it right. Do the MSCs because it could be tricky sometimes to figure out what goes on in these error scenarios. So you get to see more code now. So here, the cell manager, as I told you, is monitoring the cells. So when it receives a down message, it's because it's monitoring, it means that the process has gone down. And what you do then is you're keeping a list of cells you are monitoring there, and then you take the reference related to this cell out of it, and then you say, okay, I'll await for this particular cell with its X and Y coordinate to be restarted. So there's a little process that does that. Then it goes on and monitors that process once it has been restarted. And then you go on and you just say, now I'm monitoring a different one. I'm keeping that in my state, in the cell's state. And then at the end, you're spawning a pacer function to get the new process up to speed. And then you're just looping again. And yeah, so we could have taken it like that. So that's it. Now, at this point, there's actually a little deadlock in the code. And that happens if you have a collector process that has asked one of its neighbor about what is the content of that cell, and then that neighbor dies before it responds. It gives a response to you. And that is a problem because, as you know in Erlang, you don't get any messages unless you've asked for them. In this case, the collector will just say, I've asked the neighbor, I'm very patient, I'll just wait to the end of the world for him to come back. And in this case, he will never come back, and that means you run into a deadlock. And that's something you have to fix, otherwise you're shipping a system that doesn't work. So how do you deal with that? That means you need to go into testing. And this is another thing that is actually necessary. The minute you step out of the nice confines of a synchronous model, you need to do something to deal with asynchronicity in your system. And the answer to this is you have to use QuickCheck, and then you build up a model in QuickCheck operation by operation, and it's all based on looking at the message sequence chart for the protocol you're looking at. So you have to be slightly methodological about this and do it step by step, but then you get to something that really tests the nature of the protocol you have in hand. So what do we do here? We also have to throw tricks at it, because you can't really test an asynchronous thing without doing some mocking in EQC. Because the alternative would be, for a game of life, that you do a reference implementation and then you run the reference implementation and your process-based one for a while, and then you compare the results. But that tells you nothing about if the protocol between the cells are in order. And that's actually the most important thing. If you're doing something that's not a toy thing like game of life, you need to make sure that the protocol is working, because probably that's what you're being paid for to put in the world. So, and that with the mocking, you have a little problem is that you can't call the module under test and mock those calls. So in the fix here is you add a protocol module, which I will show you in a second. And there's another thing, sometimes you need a little bit of syncing to make sure that things have happened, because QuickCheck is actually running everything on a synchronous mode, and when it detects that you've completed an action, it will immediately check that everything has been done correctly. And if you're not waiting for your asynchronous system to do the things you asked it to do, then QuickCheck would say that you have a failing system. But you fix this by adding some helper functions, and I'll also show how this is done for Game of Life. So here is the protocol module. This is a very, very simple module. The only thing it does is an indirection of two functions: query content when you're asking another cell for what's the content of that cell at a certain time. So that's just a redirect of that one. And when you have to reply to a cell that, okay, this is my value at this given time, then it's again you have the query response, and that's again a simple indirection to the normal functions in your cell equal cell module. And it's the same trick you have to do when you have things that involve self-calls. You cannot mock them unless you put them into a separate module. But if you do it like me and you put the name protocol after it, it makes it pretty obvious what is going on, and they are very simple, these functions. This is one of the sacrifices we have to do in order to be able to test this in a sane manner. And I'm pretty sure your manager will be quite happy that you're doing the good stuff to make sure that testing is done correctly. Now, sometimes in QuickCheck, you need to sync. And in this case here, I created a function that is called collecting status. And it does something sensible. It asks the collector process behind the scenes, what is your current list of neighbors you're waiting on to give you a reply back, and what is the current count of neighbors that have are filled up at the moment or present there. And this is something that you can use for debugging. And then you should write, as I've done in my code, this is for debugging and testing only. You should not use this for anything live there. But this is just to ensure that the neighbors has been asked about their status, because that's the first thing the collector will do there. And if you don't allow them that process to run a little bit before QuickCheck checks if it has called the neighbors, then QuickCheck will say that you failed your test. So that's where you need to sync before you evaluate things on the QuickCheck side. Now, doing a step is like the most important thing in game of life there. So what you do is, and this is where you do the syncing, you tell the cell, please do a step. Go ask your neighbors, get the responses back, and go on. So here we've broken it down, and here's if we have the await collecting status. It will continue. This is a simple little loop. There, it'll ask for collecting status, and collecting status will only give you something sensible, something that's different from undefined when it's running and it's waiting for neighbors to come back to the and answer the questions the process has asked. And here I'm just doing a 5 millisecond sleep every time, and then I'm just waiting for it to say, I'm ready, I've sent out my things, and this means that I can now allow QuickCheck to evaluate if things have gone right. And then this is where you check it in QuickCheck, because QuickCheck has, when you're doing mocking, it allows you to check that you're calling out to certain functions in other modules. And in this case here, we have that we need to see 8 times that I'm calling the eagle protocol query content. So I have to ask all of my 8 neighbors when I'm doing a step. If I've not done that when I start up the step, I have not fulfilled the contract or the protocol of eagle, and then I cannot be set to have a functioning piece of code. And this is how you do it in QuickCheck. You create these callouts, and you're saying, I need to see these also, otherwise things are not working. And these are the ones you have to wait for. That's the syncing you just saw a minute ago. Good. Now, then we need to fix the deadlock. And the deadlock was that you asked the neighbor about his value, and he dies before he can reply back to you. So the way you do it is you monitor all your neighboring cells. The collector loop will monitor all the neighbors. And that means that whenever it gets a down message in there, it will make sure that it's one of the neighbors it's monitoring. That's the first branch up here, the false branch, saying, okay, I got something that I don't know what it is, and I'll just ignore that there. In the other case here, you've seen it is one of the ones you are monitoring. So the first thing you do is there you monitor the neighbor ID again. You're just waiting for that process to be up and running, and you get once it's up and running, you actually go in and create an Erlang monitor on it, and you get a reference for that there, and then you ask the neighbor again, please, what's your content? You query it for its content because it lost any notion of it had to reply you when when it died. Remember again, supervisors would only restart processes to their original state. They will not do anything to build up state that was there before. There. And then you just continue the loop here. And that actually fixes the deadlock. Now, a recap here. So you have a process per cell. And this is the key point. You can always remove them again. Throw as many as you like at the problem and see what works there. In many cases, people are throwing too few processes at the problem. So that's something you need to be wary of. And then have some short-lived processes for small tasks. Of course, when you do that and you're doing OTP things, if you have short-lived processes that you do not turn into an OTP process, you will spawn link them to your OTP process, and then if they die, you should die as well, and then everything is under control. If you just spawn the processes, you run into the issue if your OTP process goes down, all those little processes that it created will linger on, and that will cause memory leaks or other bad things in the long run. And then, again, re-emphasizing here, focus on the protocols between the processes. This is how we do Erlang. Get the protocols right, and then you will be a happy trooper. And then you use the supervisors to restart things that are going down, and again, remember, they start things in their original state. So you might have to do a bit of work to get them up to speed there. And then in this case, here we have the monitoring manager that actually is doing these things to get the cells up to speed. And in Game of Life, it's pretty simple to do it. We just ask the cells to run to the current maximum time there, and then the cell has caught up with the rest of the ones there. But when you're doing real-life things, it tends to be that you need to do something more elaborate, and then you have to think about how to do that there. But it's the same principles that I've just gone through that you should apply. Now, thinking in Erlang, and all in all, focus on the protocols, the MSCs there, and then you ask, what could go wrong here? Because this is the kind of thing that will tell you where to put in supervision and how to do it there. Tools to do all of this, there are lots of processes, spawn them for small things, use the supervisors, link and monitor, good things to keep the hygiene of your system in place, and then you can use gproc for registering and PubSub frameworks. One caveat with gproc is it's not meant to do a 300 by 300 game of life simulation. I tried that, and gproc died very, very hard on me. It could not handle that load at all. So if you go to see the code I've created on GitHub, you will see that I've substituted gproc with something else. But for real life things, you're probably not going to do something as insane as I've done here with Game of Life. Then gproc is your friend, because then you don't have to write the code to do these things and get things in order. Yeah, and then also the trick to use is timeouts. If you don't get a reply back within the time, I haven't talked about this in the slides, but these are good things to make sure that things are progressing. Have a timeout. If a timeout happens, then start thinking about, okay, something went wrong here. Let me see if I can fix that. So, and then if you're doing things involving money, and that could be banking, switching in that thing there, then keep ledgers around of what has been committed in the system. For Game of Life, there's nothing really to say I've committed this in any sense. But in other cases, that might be a good trick to pull out there when you have to start things and agree upon what happened before you died. Yeah. So here's food for thought. You can think about, because why use Erlang? What can you only do in Erlang? There, the thing you can avoid writing your own service framework. And that's something I recommend you go and read that one. It's actually a very well-written response on the mailing list there. And it is one of the benefits you get in Erlang, because you have your service framework with the processes, the OTP, supervision mechanisms and everything. You have your own service framework, so you don't have to write it yourself. That is actually a lifesaver in many cases. Then testing. Yeah, remember the asynchronous protocols are nasty. There again, use EQC, Erlang QuickCheck from QuickCheck to do property-based testing. Focus on one process. Don't try to do many at the same time. Mock calls to all other processes involved there. And then there's some work in progress in the repo there, and still a few glitches left that I'm willing to accept pull requests on to get them fixed there. And the code is here. It's on my GitHub account, and you can just go and get it. And as I said, I accept pull requests in any shape or form. And if you have questions around the code, send me a mail, and I'll try to help you decipher some of the things that are in there. I must warn you, though, if you go in there, that there are certain things I need to do a little bit of cleaning up to get right, because there were some asynchronous things that were biting my heels and knees, and yeah, most of my legs off, so they are not solved in the nicest manner possible. But a lot of the principles should be quite good. So, good. Now, if you want to learn Erlang, apart from looking at code like the Game of Life that I put out there, then you have to think about if you want your life, if you think your purpose of your life is to serve as a warning to others, or if you want to do something that is remembered for anything but a drastic disaster there. So you should take some training to do that. Don't just do it. So you can take training courses from Erlang Solutions, of course. I have to say that. They're good here. Or you can learn you some Erlang online and read through that book and get you something going there. And then you can use the Erlang questions mailing list. All of these are things that I recommend you doing, so you can get up to speed fast. Because in the ESL training courses, a lot of the thinking that I've been talking about here is what is in the exercises, and if you use it right, then you can actually do that. So, and then do it hands-on. Erlang is not a language you learn about by reading about it. You need to get your hands out of your pockets on the keyboard and into an editor, and then start slapping some code together. That is what makes you learn it. And then, because Erlang is so different from everything else, give it time to sink in. If you're spending just a week on Erlang and then you say, I don't really get this and it's just weird stuff, you are cheating yourself. Give it time to sink in, because as I said earlier, Erlang is an outlier in the landscape of programming languages. The golden trinity of Erlang is what makes Erlang very, very special. It takes a while before you understand how to use this. But here I've given you some hints in this presentation. So go and use those hints and experiment with things there. And even, even if you never get to write a commercial system in Erlang, just doing some Erlang and starting to do some of the process-based things that I've been talking about here, about processes with protocols in it and how you look at that, it'll make you a better software engineer, even if you have to write Java for a living there. So, and then a word on Elixir, because those are things that keeps creeping up with those questions there. It's built on top of the Erlang VM. It has a more Ruby-like syntax. It's just hygienic macros, so it's easy to do DSLs. We are doing some work on a Lego Mindstorms library with Elixir, and we've done a DSL for that, and that is actually quite nice. Unfortunately, I was not the one that got the idea. It was one of my colleagues, Jimmy Söger, but it was really good code, and you can ask for links to that code as well if you want to see that. So anyway, what Elixir does a lot better than Erlang is the support for data handling is a lot better in Elixir. So some of the quirks you might have in Erlang with records and other things that are, well, a bit 90s in their way of looking at the world, it's better in Elixir there. But this is what you have to remember. If some hipster is raving about Elixir, we can calm them down and say you still have to learn the Erlang programming model. Elixir is running on the Erlang VM, so lots of processes, understand how to embrace fail-fast and supervision. If you're not doing that in Elixir, then you're basically doing Ruby on the Erlang VM, and that is not going to make anybody happy in the long run. So key building blocks, here we have it, the Erlang, the golden trinity of Erlang, share nothing processes, message passing, fail fast approach, and link monitor concept. These are things, work with them, play with them, see how they can be used to solve different things. It's something that will change the way you think about software in general. One of the things, an anecdote here at the end, is that when I worked at Motorola, we did a product in Erlang from the ground up. But the more we got into it and the more we understood the existing project, we realized that they'd actually been rewriting like 50% of the Erlang VM in that other legacy product. And that makes you go, the concepts of Erlang is something that creeps up again and again. And then the question is, do you want to get it almost for free by just taking Erlang, or do you want to be a man about it and write it all in C from the bottom up and lose all your hair and grow a gigantic beard? It's up to you. I've chosen to go for the Erlang route, so I still have my hair. So, and then this is where Erlang, for all this, makes you a happy true base, because you can deal with the failures in a program, in a system, because you have a language for it. In other languages, you have, well, sort of a language for it, but you basically have that you have exceptions, and you need to do a lot of try-catch on exceptions, and that is, excuse my friends, very, 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 very ugly to look at. Erlang, on the other hand, accepts and embraces failure by saying things will go wrong, you need to deal with it, and that's what the beauty of Erlang is. So, if you want to get in touch, you can contact Mladen there, and if it's on the code, go to GitHub and pop me a mail if you have questions regarding the code. Thank you.
Torben, I'd like to thank you, and I'm sure everyone will join me in thanking you for a very compelling talk on Erlang and indeed thinking like an Erlanger and how to sort of get to that position. So I'm glad to say that, as ever, we've received a bit of an avalanche of questions, and they typically arrive faster than we can cover them, so I'll have to apologize to begin with to everyone whose questions will not be answered simply due to the available time remaining. But to answer as many as quickly as we can, Torben, we've had a really interesting question from someone obviously looking to start in Erlang. And Martin is basically asking, from a perspective of a typical, in inverted commas, non-functional programmer, how long does it take to become a productive coder in Erlang?
Yes, Martin, that's a very good question there. It all depends on your background, but I would say that I did some metrics on this while I worked at Motorola, and my impression is that anywhere from between 1 to 3 months of time, then you're back at the productivity you had before if you were doing C++ or Java. And then after that, then you end up being about 4 times as productive after 1.5 years of it. But within a month to 3 months, you're back at your old productivity. And I think that is pretty cheap there. I know that it'll take me longer to be productive in Java if I had to go in and learn all those libraries that you need to do to be productive there.
Thank you, Torben, for that. I think that sort of gives a pretty concrete answer. Just to try and, again, answer as many questions as we can, Piotr is asking, is it possible to move logic from cell manager to supervisor?
You could try and do that, but it would make things clunky, because you basically have to rewrite the supervisor behavior to really do that. I think the key point with Erlang, the OTP supervisor, is use them for what they're good for, which is to restart things. You have a known starting point, and then whenever you need to do fixes to clean up, start something like the cell manager on the side and let that do the cleaning up. It makes your code a lot easier to do there, and I'm pretty sure that the things I'm doing in cell manager, if you go and look at the code, I don't think you can do that in a supervisor without going through tremendous hoops there. So I would recommend this approach. Also, take some software in, let it do the job it's good at, and then only do the things that are missing.
Thank you, Torben, again. And again, apologies to everyone sending questions. We're getting about 3 questions whilst we're answering, the one question that's being asked. So again, we'll try and answer as many as we can. So to move on this particular topic, Torben, a person is asking, what is the benefit of the cell manager? When the supervisor restarts in its original state, can't the new process simply check if it needs to speed up as part of the startup process? So if you'd like me to repeat that, David is asking, what is the benefit of the cell manager? When the supervisor restarts in its original state, can't the new process simply check whether it needs to speed up as part of the startup process?
Yeah, you could probably do it that way. And the reason why I didn't do it that way was that I realized that I also needed to keep a count of the processes, because I had, if you remember, I threw out dproc as a way to get the process identifier for a given cell, and that is also a part of the cell manager's job, is that you can get an idea about what is the process identifier for a given cell, and then it became natural to throw in the monitoring in that module and then do it from there. That's the reason why the code ended up like this. I think I'll have to go back and see a little more careful into letting the cell actually do the speed up there. But I rejected it at the time for a number of reasons which I have forgotten about right now. But I'll go and revisit it because it's a good question. But I think my idea about doing it was also to have the registry there, and then it made sense to keep the monitoring over there. But I'll go back and revisit that. It's always good to go back and revisit your code.
Thanks for that, Torben. And now, really interesting question we've received from Felipe. Felipe is basically asking, why are many existing Erlang applications sequential, in need of parallelization, if Erlang is such a powerful parallel tool?
That's a very difficult question to answer, but I think one of the things that you can do with Erlang quite easily, if you pick up some framework, say like yours or Cowboy, you actually get rolling on doing something, and you harness the power of Erlang's parallelism by using those frameworks, and then the code you're writing ends up being quite sequential because the parallelism concurrency happens under the hood. And adding to that is that a lot of people, when they start out in Erlang, they haven't lost their past, so to speak. You have to forget about how you write code in normal languages and start working with concurrency and do that. And I think a lot of the code that you run into, that people have started out and only over time do they realize that concurrency is your friend and you have to embrace it more. I think that's the reason behind it. But for individual projects, it's a case-by-case evaluation, and I can't give a definitive answer on that.
Thank you, Torben. I'd just like to take a second and thank everyone sending questions. We are receiving probably a record number of questions at a record speed. So clearly the webinar has stimulated a lot of interest, and a lot of people sort of are actively thinking as we speak. So to move on to the next question, Antonio is asking, for storing variables with a high access rate, is gproc the best solution, or should we perhaps bypass it and use ETS?
Antonio, this is what I had to do. So you were spot on. gproc was simply too slow there. So I had to throw in ets in here, and that's what the cell manager process is doing. It's bypassing gproc, and it's going directly into an ets table there. And that is actually a common concurrency pattern you will see in Erlang, that when you have these things that you need to read a lot and have access to that, then you create an ets table, let everybody read from it, and only synchronize through a process when you're doing writes to it. The typical Erlang concurrency pattern, and that's what I used here for the cell manager.
Fantastic, thank you, Torben. Just to move on straight away to the next question, Errol is asking, is it possible and indeed common to use Erlang or OTP just in a supervisor role to manage non-Erlang processes, for example, .NET via ports, for example?
Yes, I'm not saying it's common, but you can definitely do it there. And depending on the problem you're looking at, it might be a very good idea to mix Erlang with something else if you have existing logic in it there, because then you get the good concurrency for the I/O things in Erlang, and then you have your existing business logic managed through a port, and if something goes wrong, you can just restart that port. So it's very doable, but I'm not sure that it's very common.
Thank you, Torben. Another question from Carlos. Carlos is asking, when we're looking at more real-world applications, would you normally keep one process per cell or customer, even if it is not active or connected?
Oh, that's a good one. I think the simplicity rule applies here. So you would model everything by having each user being a process, but then you also need to be wary of the memory consumption, because if you have 1 million users and not all of them are active, it could be wasteful and harm your memory usage if they're all alive. So what you do in those cases is you put some timeouts into your system, and if you have no transactions on a process for a while, you hibernate it, and then that's where you can either hibernate the process or do the most sensible thing, which is to store the state related to it, and next time the user logs on, then you get the state or the information about that user out of that stable storage that you've used to do that.
Thank you, Torben. Unfortunately, we have time for just a couple of further questions. Rajiv is asking, why wouldn't you just simply let the supervisor bring the dead process back to restarted state instead of the monitor?
Because you can't do that in the supervisor, as I said earlier, without going through tremendous hoops, and that sort of destroys the purpose of the supervisor. And again, if you go in and if you're ever allowed to see some of the code that Ericsson has written, then this pattern of having a supervisor that's just responsible for getting something restarted, and then having a process on a monitoring process on the side that does something more elaborate to get things back into shape, it's a very common pattern. And if you can also go, I can't name projects right now, but there's a number of open source projects with Erlang where that approach is actually used as well, because you don't pollute the supervisor, because most of the things I'm doing in the cell manager is impossible to do in the supervisor, and it makes for nicer code to just put it outside.
Okay, Torben, and thank you for that. And one final question from Kai. Kai is asking, are there any tools available for the flow diagrams?
Yes, there is. There's a free one called Plant UML. Abstract the fact that it's made for UML. The sequence chart thing there is amazing. It's text-based and very easy to use, and that's what I've used for all these diagrams in this slide deck.
Thank you, Torben, once again. I'm afraid that's all the time we have available for today. Now, once again, I'm sure everyone will join me in thanking you for a great talk on how to think like an Erlanger. Many thanks to all of you who have joined us for the webinar as well. There are a lot of questions that haven't been answered. All of those questions I will personally pass on to Torben, and will answer them and obviously send them back to you using your email details. Now please join us again for our next monthly webinar. Following today, we will be sending you a very short survey to make sure we capture your feedback of today's webinar. Please also note that the recording of the webinar and the presentation that was shared today will also become available for you to collect on Erlang Solutions' corporate website at www.erlang-solutions.com. Thank you very much once again, and we look forward to seeing you on our next webinar.